Now you can hear me. Okay. Okay, great. I was like, oh, I'm gonna do this. I'm gonna do this. I don't need to talk to chat because I'm just gonna try to get this video out in a hurry. And then I was like, why is everybody contacting me? It's because they're trying to help. Okay, let me. Which is good because I actually wasn't really happy with how that started. Hello. um. So hi. Let's see. You look. I did know what I was talking about. Okay. I am going to. I'm gonna. Okay. Yeah. Thank you for that. I have 50 minutes before my next meeting, and I'm trying to bang something out. I guess I'll talk to chat for a second. Hi, chat. So here's the situation. I got to put you back into streamer mode. Hi. So here's the situation. Um, I have. So I got these. So basically, what am I doing? Um, I am. Can I mute things? Oh, that's what. Anyways, so basically, I'm going to be doing a review of a free mocap recording that we got from a user on the Discord and on the Reddit, a friendly fellow by the name of at use who's your Mikey slash MB. I should write this down because I keep forgetting. MB engineer or something. Da 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 da. Da 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 da. What did he name himself? MB engineer. MB Mike engineer. Where's something to write down? MBENG Mike, which mostly is just going to be for the Twitter post that I make about this later. And hello, Ask JM. I ask EGM, but I am JM personally, so I take it as such. But yeah, so I'm gonna be doing kind of so they posted their their recording that they were able to successfully get in the garage, which is super dope. And I figured like this might be a nice mechanism for sort of helping the community get better at like building like the intuitions that need to be built to sort of get good recordings like this, because there's a lot of things that are like not particularly intuitive about it, that kind of like I can see it when oh yeah, like do it like this, do it like that, you'll get better results, but I don't really have the energy to like write it out. So I think if I can sort of get practiced at making these kind of like what are they called, reviews, basically reviews, then I could potentially like bang them out and like have people be like, hey, I got a recording. You're like, okay, cool, let me give it like a little 5-minute critique. 5 minutes, yeah, as if like I'll get any, but anyways, maybe 5 minutes. I think that it's one of those things that like if I do, the more I do, the better I'll get at it. So I'm gonna start with this one and be a little sloppy with it, and then the next ones will be cleaner. So with that, I will. Okay, with that, chat pause 2 to scroll. I'm gonna kind of minimize the chat and just try to get through this bit. And hopefully, actually, can I do a thing? I'll say review start. I'm trying to like, so I can do things like that and then like search for it later, right? People do that to like help them clip out their streams. I don't know, whatever. Increase N. That's how you get better at stuff, where N is just the number of times you've done it. Don't try to do things perfectly. Just try to do them at all, and you will get better over time. Okay, I'm going to move my camera from streamer mode into this mode, which is to say I took it. So this is the computer that's running OBS. So like if I'm looking at chat, I'm looking at you. Yeah, but this is like my working screen. So this is, anyway, here we go. All right. Oh, let me get myself centered there. And what's my schedule? So I want to, fuck, I'm just gonna wing it. Okay, and let's see. Getting started in 5, 4, 3, 2. Hello, and welcome to the first installment of Free Mocap Reviews Free Mocap Sessions Session 1 of that. This is a free mocap reconstruction, animated video, matplotlib output. Who's it from? Oh, hey, from Who's Your Mikey? You just popped into the Twitch. I could be talking to you directly because we're doing this, but I'm just gonna pretend like you're not watching, and we'll go through that later because I'm trying to bang this out. Okay, head in the game. Yes. So Who's Your Mikey, who is here now, posted this on the Discord and on the subreddit, and it's I think a really nice example of a solid recording that I will now go through and critique in the sort of classic academic sense, which is you start by saying, "Wow, this is great," and then you talk for half an hour about everything that you see that's wrong with it. But really, it's that first, "This is great," that is the key component here. And then everything else is, a donation of time and interest. I always tell students that criticism is a compliment because it means that someone has cared enough about your work to look at it and see the ways that it could be better. So let's do that. These users are, first of all, I just want to say how much I love just the structure of this, because this is a dad and who's an engineer. We're working with his son, and he's we're working through the code, and we're interested in these biomechanics questions, sports biomechanics for hockey, I guess, and we're also interested in technology, which is how great is that to build a software that can be used in this way. So let's talk about it. So I wrote some sort of notes here, but before we go into that, so this is the video. So the process of me getting this was that Who's Your Mikey /MBN Mike on Twitter took the session folder that was produced by FreeMocap and took the entire session folder, it made it into a zip file, and then shared that zip file to me through a Google Drive link. And then I took that folder, unzipped it into the FreeMocap data folder, and that's right here. So there's currently a weakness in the pre-alpha software, which is that there's this really helpful structure where the folder is named by the session ID, and that session ID is sort of propagated through the files that live in the session folder, which is convenient in a lot of ways, but it has this kind of issue where I would like to change the name of this folder to specify that it came from somewhere else. But doing that will kind of break the reconstruction because it expects that to be the session ID. So that's one of those things that's that's a problem that's just it's going to go away when the alpha version comes out with the 0.1 plus. So it's just kind of okay, well, it's fine for now. So I took that folder, plopped it in there, and then reprocessed it with this simple script. So don't worry about all that. This is the relevant part. So it's import freemocap, freemocap.RunMe, which is the main workhorse. So if you just do that, it will just run, well, it'll break for all that, but this will just run everything with default settings. And I wanted to reprocess this, so I turned session ID, I set session ID to be equal to the relevant session ID, which is up here. It's also the name of that folder. I set the stage to equal 4, which is the media pipe processing step, but I turned run media pipe to false. The reason why I did that is I didn't really want to reprocess the videos. I just wanted to turn on this save annotated videos equals true. That's an experimental feature that saves out the videos with the media pipe overlay on top of it, which is helpful for what's happening in a second. But the most important part was use Blender equals true. So I wanted to set this up to stuff all the data into a Blender scene, which I'll show you in a second. If I didn't want to do the annotated videos, I could have just set stage equals 5 and then leave out the rest of the stuff. Anyway, so when you run it like that, it will produce a blend file, which will be just dropped right in the outer folder of the session folder, and just .blend. And if you double click it, it will open a Blender scene, which I've already done, and it will look like this. So this is the default as it comes out, sort of there's still things are kind of in an arbitrary reference frame, and it's in this sort of, what is this called? Viewport shading mode. But if you push Z and then select material preview, which is the same as clicking on this guy up here, doink, you can see the videos and start moving things around. So let me just shift this stuff around. A lot of this stuff I'm doing now is going to be automated away in a bit, but we'll do that later. I also don't have screencast keys, so I'll just say what I'm doing. I'm pressing G for grab, Y, so it grabs along the Y dimension, moving it out, R for rotate, X to rotate around the X axis, rotating that down so it's like roughly equivalent there, and grab on Z, lifting it up, basically trying to move the friendly skeleton, rotate X so that they are standing roughly on the origin. For some complicated factors, this quality of the skeleton here is not, I don't really expect it to be that good, but it does help us look at some things. Basically, the recording wasn't set up to get a high quality skeleton, which, because of course it wasn't. How could it be? Okay, then I'm going to turn this off, and let's see how we're looking. Oh, where'd you go? Oh, there you go. Okay. Yeah, so we got some issues there. And pop. I want to get the feet on the ground. Doink. Yeah. Yeah, it looks all right. And now I'm going to grab you, grab X, joink, and grab you, grab X, joink, grab X. Okay. And save that. Nope. Just save. Just save where you were. Thank you very much. And now I'm also, just for the help, for sake of the conversation, Shift A to make a new thing. Images as planes, which is an add-on. And this is the folder. And I'm just going to select that animation vid and grab in the Y, rotate in the rotate X 90. There we go. And grab in the Y, push it back, scale it up. Cool. Now we have everybody who's relevant in here. Okay, I'm gonna let this play and see how it looks. Cool. All right. Love it. Save you too. Okay. Actually, let's see here. Yeah, I feel okay about that. I think I'm actually going to take some space up on the screen to show this because I think it does actually. It's helpful to have that. Shift. And snap right and snap left, and then do that, and now we're good. Okay, it's not going to be synced up. Actually, I guess I could try to get it synced up closer. And play, close to synced up. Okay. Cool. So let's talk. So I was like trying to think about the, what was I saying? I was like, as I was preparing to do this review, I was like trying to think about like what are the relevant notes to talk about. And I realized it kind of comes down to a couple of sort of key sort of areas. Sort of the settings that were used for the reprocessing, the environment that was set up for the recording, the placement of the cameras, which is part of the environment, but it's sort of, it's important enough to get its own space, and then the sort of the technique in like the recording and like setting things up and sort of actually getting the recording. And so let's go through that list. So the first thing to talk about are the settings. And I have critiques here, but mostly they're critiques about myself because it looks like you use mostly like the default settings, which makes sense. But there's a lot of ways that those are not ideal. So let's look at in the folder here. This is the right one. Let's look at the config YAML. And yeah, look at that. So I'd say the two main factors that will determine like the quality of the recording are the resolution of the images of the video, and then the exposure. And the frame rate obviously matters too, but actually the most cheapo webcams are 30 FPS no matter what you tell them to do. So I think this is one of those classic like buttons that doesn't do anything. So whoops, sorry about that. And so the default parameters for the resolution, width, and height are 640 by 480 because historically we would struggle with recording at higher resolution, and it's also it's like those are the defaults, and I have a very powerful computer, and most people in my lab have pretty powerful computers, so we can handle higher resolutions, but I don't necessarily want to put the settings to block people out if they don't have that good of a computer. I have had a lot of success recording at 1280 by 720, so 720p. So if you can run that on your computer in that sort of setup phase, you'll want to, if you can bump that up to 1280 by 720, then you'll get, it's more pixels being recorded, which means that the neural networks doing the tracking will have more information to work with. These neural networks work kind of on the basis of like Shannon information and entropy. So there is a sense where just having more pixels associated with the subject will give better tracking. So give it a try at 1280 by 720. If you have issues with the frame rate, bump it down and you'll be fine. The other important factor here is the exposure. Where the exposure you want to set to be as low as possible while still getting a good quality recording. And where good quality recording means that you, with your human eyes and giant human brain, can look at the picture and say, I would be able to draw an X on all of the joints that I'm trying to track. And if you as a human can do that, then the neural network you're asking to do it for has a chance of being successful. If you look at it and you're like, oh, that's too dark, then you shouldn't expect that the neural network will be successful. So you kind of want to set up the environment. So basically that exposure setting, you basically want to bump it down and get it as low as possible while having the picture still be like recognizably human. The reason for that is that exposure setting is it's a digital camera, so it's not a real shutter, but it defines like how long the digital shutter, so you have a 30 FPS camera because every frame is 30 milliseconds long. And that means that the maximum exposure that you could have the sensor recording light is 30 milliseconds, 33 milliseconds. But you can also shorten that amount of time basically as much as you want. And the shorter that window is open, the less blur you're going to get. Like if I'm moving my hand, you're seeing my fingers blurring because if the shutter is open for 10 milliseconds, then the distance that my hand travels over that 10 milliseconds will be blurred across the image. So you want to have your pictures be crisp, so you want to turn that exposure as low as possible. Of course, the trade-off there is that the images will get darker. So you want to have a very brightly lit environment so you can get the exposure as low as possible. So -5 is probably too high, and that is, I think, one of the main thing that's determining the quality loss that you see during the part that you actually care about, which is the what's it called? The actual shot. I'm from Texas. I don't know much about hockey. Because you can see basically his arms start to blur during that part of the slap shot. And so because the arms are blurry, the track on the arms gets worse, which again, like from the perspective of like, you tell the friendly computer and the friendly neural network, please track the hands on this video, which is already an impossible sci-fi task, but somehow it's able to do it. And then you give it, and it's doing that on each frame. Let's pretend like it's doing it on each frame. That's a little bit, let's pretend. But then you give it this frame, and it's like, well, I don't really know where the hand is because all I see is this blur. So you can't really expect it to do a good job. And so part of being successful in these things is setting things up that the neural network has sort of all the best chance it can to actually be successful. So let's see, that's the settings, exposure too high. And so those settings could have been altered to give better success. But of course, I'm guessing that you may have already done that and you sort of set it up and you said, okay, I'm getting that exposure as good as I can, and -5 is where we get a good track. This actually gets into, which is basically means that you need to make your environment brighter. So this is a great setting. It's a garage. It's big open space. You have sort of empty space in the background. Not a lot of visual clutter in the background, which is also good for getting good tracks. But the downside is that there wasn't enough light in here. We tend to suffer, actually not suffer, but this gets into like an interesting feature of the human visual system, because our visual system adapts to different light levels tremendously efficiently. You can see outside in a sunny day. You can see outside like at dusk, even though there could be like a millionfold, like a 7 order of magnitude difference in the actual lumens of the scene. So we don't notice that most indoor environments are many orders of magnitude dimmer than any outdoor scene. So to get a better recording here, you could either like set up some lights if you have like spotlights in your life, or even just like desk lamps and stuff like that. I don't know if you can see that. Pointing at the scene can help. You see, like, this is what it looks like when things get overexposed. Or another option would be to just flip your whole recording around and open the garage door on a sunny day, and then turn your cameras to face the other direction. Which the sun is so incredibly bright that will probably allow you to bump your exposure settings down to something closer to like -8 or -9. I try to live at -7 or lower, but lower numbers are better as long as you can get a crisp image. Now there's a trade-off there, because if your garage is like most garages, the other side of the view here might not be this nice clean white background. So there might be like visual clutter in the background that might also lead to some lower tracker accuracy. So you could either try it, check it out, see if it works, or like put like a drop cloth or something back there to give it a cleaner background. Sort of that becomes the trade-off of like, how much effort do you want to put in versus what is the expected increase in quality, and we'll see there. Quick side note on this while we're here. Looking at these traces on the bottom here is another good way to sort of evaluate the quality of a recording. These showing the hand position over time is kind of a holdover from the fact that that the original video that I made this for was a juggling video, so it's like showing the hands and the balls. But this winds up being a really nice output of sort of visual output to show you the quality of your track. Because the hands tend to be the most mobile thing, so if they are tracked well, probably other stuff will be as well. And you can see sort of left, it's kind of weird that I'm separating so this is the vertical dimension, this is left, right. It's a little, I guess I don't really know what that means. I probably mean, this is probably Z and this is probably Y, I don't know. But you can see this sort of, the way that the trace of each hand sort of goes like that sort of like wobbly thing. Like your hand doesn't really do that, and you can sort of, like it does, I can do this, but during this movement, actually, can I, oh I can. I'm not going to go back to Blender here because I can increment through the frames. So you can see if I zoom in here, yoink, if you watch the recording, watch his hands, he's doing a nice smooth movement with his hands, but the trace of the data has this jaggediness to it. So something has gone wrong. One of the really nice things about this type of a recording is that you have the videos right there. So you can look at the videos and be like, I don't really think his hands did this. And that can help to diagnose. And this is sort of important for this stage of the sort of the tool building process. Because, this is, maybe you're an animator, maybe you're an artist, but I'm a scientist. So I think of this as a research tool. And, it's a sort of an interesting stage of building the research tool where I don't trust it. I don't trust the data that it gives me. So which is part of why this visualization is set up this way, is to allow you to look at both the data and the video. And so I can use my human intuition about videos, which I have many, and use it to evaluate the quality of the recording. So you can see that as the hands go forward, as they start moving faster and they sort of get blurrier, the track gets worse, and that's where you get these sort of wibble warbles in the resulting 3D animation. And you can kind of, so the 3D animation is derived from the different 2D animations. So like, even if, and it's not particularly sophisticated about the way that it evaluates which of these are good images and which ones are not. But you can see like this one has lost track of the hand, and so the resulting visuals, like it's going to get the 3D wrong, and it actually looks like it doesn't even, no 3D reconstruction of the arm actually makes it through, meaning it probably dropped below some threshold value, and so the result is that this track, which is based off the 3D track, got all wibble warbly. Let's see. So, okay, yeah. So settings are good. Could have bumped up the resolution. Exposure was too high, which led to blur, so you could bump that down, but then we need more light, so you can add more light to your scene in these various ways of bringing the sun in or bringing in spotlights, but you have to deal with the visual clutter in the background if you move to a different environment. Or you don't, just try it, see if it's a problem. And that leads us to this other one of camera placement. First of all, camera placement, not bad. Because mostly, you know it's not bad, because it mostly worked. However, beyond that, so with these kinds of reconstructions, you're doing a triangulation of, so you have multiple viewpoints that each get a two-dimensional image of a scene. And so we then do the 3D reconstruction by triangulating through those 3D points, right, okay, so you have 3 cameras, each of which gets a two-dimensional view of a three-dimensional scene. This Charuko board thing is a calibration tool that allows each camera to determine its position relative to its other camera friends in order to build an estimate of the camera's 3D location in space. That data about the calibration lives in this, we're back in the session folder, this calibration.toml file. If you open that, that will tell you the calibration information of the camera, and that includes what's called the camera extrinsics, which is the position of the camera. It's a 6 degree of freedom position, meaning there's 3 translation elements, like an X, Y, Z position, and then 3 rotation elements. So there's like a rotation around each axis. And those 6 numbers, those 6 degrees of freedom, specify the camera's position in 3D space. There's the camera matrix, don't worry about that. The distortions, which deals with the lens distortions of the camera, which let's forget about that for now. And then there's these rotation and translation vectors, which specify the camera's position in 3D space. And the units are millimeters. So if you entered the size of the Charuko square accurately, so if you measure this square out in millimeters and then input that to the RunMe file with the Charuko square size equals that number, it will scale things appropriately. If you don't specify that number, it will use 33 millimeters, which is the size of the Charuko board when it's printed on an 8.5 by 11 sheet of paper. This works just fine. The only main issue is that you have to be pretty close to the cameras for it to be able to see. That was why, so Mikey did the first reconstruction. The skeleton was small because it was being scaled by the wrong amount, so the values came out to be inaccurate. This one should be accurate. So if we were to go through the effort of, it pops in, like the feet get messed, like there's like one frame at the end where it's good. But like theoretically, if we were to, oh, come on, man. Oh, it's also just rotated wrong. Theoretically, this skeleton should be the same size as the hockey play-in subject here. Right. So camera placement. So you're looking at things from 3 different points of view. And I think I can do this. Can I turn on this? This? Yes. Yes. And then I can look at this. I can look at that. So if this, so if I have this, can you see that? Yes, cool. So this is your friendly subject. And then this is camera 1's viewpoint, and then this is camera 2's viewpoint, and then this is camera 3's viewpoint. When you are setting things up, so let's say camera 1, 2, 3 camera, and then each of these cameras is getting its view, and then that's going to be used to do the triangulation and reconstruction. So what that means is that the quality of the 3D reconstruction is sort of dependent on the setup of the cameras. And one of my main criticisms here is that the cameras are pretty close together. You know, you might have sort of extended that might be all you can get. It might be that you can, you might need like USB extenders to get them wider. Because the issue is that, so if you're triangulating on the basis of like the difference, the viewpoints from these two views, this angle, the closer the cameras get to each other, the smaller that angle is. And so that means that any noise in the track of one of these cameras is going to shift this 3D point out by more. So if this camera moved out, so now it's getting it from sort of like a different viewpoint. Can I do that? No. Then it'll be getting a different field of view, and sort of that angle will be a little bit larger, which I guess can lead to problems, but basically it can lead to a higher quality reconstruction. Intuitively speaking, and again thinking back in that sort of information point of view, if the cameras are close to each other, they're getting roughly the same image of the person. So if you move them around, then the cameras will get different viewpoints, so that it's just more information about that scene. And in particular, you can kind of see, yeah, this is actually a good example. So because all the cameras are kind of looking kind of from the same perspective, they're all having kind of a hard time seeing that back arm, which makes sense because it's occluded from the camera. So if you were to get like a wider angle on the cameras, then the camera that's over here will see a better view of that front arm, and that could be used to help the reconstruction. So again, I know there's sort of like physical limitations involved, but that's kind of the things you want to think about. Another complaint, if I were to be making them, which I clearly am, is that this camera has a lot of wasted pixels. So it's a really nice recording because it's like a simple task where the person is more or less staying in the same place. But so everything that's outside of that range is wasted information, right? You're recording pixels that you're not actually using in the reconstruction. So you can move that center camera closer to get the person to take up more of the image. And these ones are better, but similar. You could say similar things. There is a version of this world where we are tracking the hockey stick too, using some like deep lab cut model, or like you just wrap it in, like you put like neon tape on it or something like that, but we're not there yet. We'll get there. But yeah, so camera placement not bad. Could have had a wider separation of views, and the middle camera could have been a bit closer to have fewer wasted pixels. Problem that is exacerbated by the fact that you're recording at 640 by 480. So if you had this at 720p, then for the same distance you get more pixels on the subject, and so that's more information for the neural network to try to attach to when it's actually trying to do the tracking. And what is that? There we go. Technique. Oh yeah. So now let's talk about the technique. So first of all, the best thing about this is that it did in fact work, which means that the technique is good enough, is successful. It was a successful reconstruction, and everything else now is about honing things. I kind of love this. This method of using the Chirurco board this is such an efficient recording, and I appreciate that you managed to get a calibration and an action in like 208 frames. That is an efficient move. However, you were close to being unsuccessful because the Chirurco board was not visible for that long. I think if I set this, this might break some things, but I'm not that worried about it. I'm setting stage equal to 3 because I wanted to run through the calibration part again, which won't take very long because, yeah, okay. Stop. Okay, so this, it's fine. You can see the stuff going on there. So the yellow is getting into the calibration stage 3, which is the calibration stage 3, which is the calibration stage. And this is some of the default output from any pose, which handles the calibration, so it's not as obvious as you might like. But these numbers show, so camera 1 versus camera 2. This shows the shared views of the full Charuko board between each camera. So camera 1 and camera 2 had 20 frames with a shared view. Camera 1 and camera 3 only had 7. Camera 2 and camera 3 and camera 1. Yeah, so really camera 3 had less than 10 viable frames to record, which I think anything greater than 1 will work, but that means that you were 300 milliseconds away from this being an unsuccessful calibration. Yeah, and I'm not looking at the chat, but if I were to be looking at the chat, I agree that this is very useful information that unfortunately is not, it needs to be highlighted more. I talked to the creator of AnyPose, Pierre, oh God, his name starts with a K, last name starts with a K, and this is the output that he put in there, and I basically got permission from him to like fork that repo and make a bunch of changes to do things like highlight this information, because like I can look at this and be like, oh, yada yada yada, but like how could you ever have any hope of knowing what these numbers mean? Actually, while we're at it, actually, no, there it goes. Because yeah, I want to show, while we're at it, I'll show the rest of it. So this is saying you've got enough shared views to start the calibration process, and then it bumps into this, which shows you your initial error, which is low, and then it runs through this, and then now it will stop that. Okay, stop. There you go. This is now running through the bundle adjustment, which is basically jittering those camera positions and the 6 degree of freedoms of the camera to minimize reprojection error, which is, talk about that another time, but it's basically a measurement of how good the reconstruction is. And the relevant data here is this center column here is the cost, which big numbers are bad. And you can see it starts with roughly 500 pixels of reprojection error, however that was calculated. And that drops down to about 14 over the course of 10 iterations. If you have more pixels, more frames, this will take longer, but it'll also produce better data. Oh, and then the initial error was 0.49 average pixels of reprojection error, I think is the numbers. And then that gets cut less than half by that bundle adjustment, because AnyPose is cool like that. Yeah, anyway, so the downside of your very efficient technique is that you were very close to being unsuccessful, because camera 3, which I'm guessing, actually I'm not sure which one is camera 3. Is it video 1? I guess it would be this one. Oh, had a hard time. Also, this is a very dangerous finger right here, because you are potentially occluding one of the Aruko markers that is underlying the board. So even with the best view in the world, it wouldn't have been able to do a full board reconstruction from that, which I think that matters. I'm not 100%, but so just be careful when you're holding the board, just to hold it from the edges and on the white side, and try not to get your fingers on the actual track markers. Again, kind of being, there's a very helpful form of like empathy that you can have to the computer that you're asking to do work from, because computers are very, very good at what they do, but they cannot think outside of the box at all. So if you say, hey, find all these Aruko markers, and then you do this, it's like, it's not going to be successful, because how could it possibly? But yeah, so it's actually also there's currently an experimental feature coming up in probably version 0.0.53 that allows you to basically reuse saved calibrations, which people have been asking reasonably for a long time, to allow you to use like the more traditional motion capture workflow, which is to you set up your cameras, you calibrate, you save the calibration, and then you do another recording to do the actual skeleton tracking. So that mostly works. I have used it. I want to test it a little bit more on our end before we push it through. But once that goes through, you won't have to do this sort of like super efficient thing. You'll just need to, you'll basically set up the cameras, do your calibration, and then do the next one with the regular recording, and it will just use the calibration from the previous the calibration data from the previous calibration. So as long as your cameras don't move, you'll be able to get a good calibration without ever showing the Charuko board. And that'll allow you to sort of like, take your time more and sort of like make sure you're getting like the full view, getting a lot of viewpoints to give that bundle adjustment more information to work with, and you'll be good to go there. And that will also potentially free you up to do something that would help with a blender reconstruction, which is to give like a full like A pose. So like standing with like palms facing, I think you want palms facing the camera. I'm still playing around with which is the best procedure there. But part of the reason why the skeleton is having a hard time here is because the part of the issues with the calibration, but it was sort of, it never really saw his fingers. And if he did, it was far away at a 480p image. So you could have it do that recording, which sort of gets in the same question of like, you should also be able to record that offline and have that load in, so you don't have to do the A pose, because it's like he's already standing there holding the hockey stick, so you don't have to like do the A pose, pick up the stick, do the thing. That's not the great workflow, but it's fine. Oh, and again, I'm not looking at chat, but if I were to be looking at chat, the thing to measure here is the edge of the black. When you're measuring the Charuko square size and entering it in the RunMe using this keyword argument, 36 is, again, the size of the square on an 8.5 by 11 inch paper. 58 is the size on this one, and you're measuring the edge of one of the black squares, not the white squares. So if you don't specify this at all, the units will come like, if it was set to 1, then the units will come back to be in units of these square sizes. And by units, I mean like the numbers, like the actual numbers. This is XYZ, so the XYZ values would be, the units would be that. So, but if you scale it, if you put that number in to be an accurate measurement of the squares, then the units will come back in millimeters, which is the traditional unit of motion capture. Let's see. Do I have anything else to say? I think that's about all I had to say. And like, I don't know, half an hour left. I'm a scientist, so I live in SI units, so I like meters and kilograms. You may not like meters and kilograms. You may prefer inches and feet and pounds and stuff, which, not here to judge. But if you ever submit a paper, if I review a paper you submit, you have to use metric. But if you're just living your own life, you can use whatever units you want. So you can enter that unit in whatever you want, whatever unit you like. This will come out looking a little weird because it's sort of like hard coded to fit like like metrics. Actually, it might work. It will look a little weird, but this, you could load it into Blender, and then there's a place in Blender you can set the units to be whatever you want them to be. But that's on you. As a scientist, I will respect your decisions, but I will not necessarily. I won't divert my own energy towards making life easier for inches and feet. But I am not a metric chauvinist. There is a value to the imperial system, just not in the sciences. Okay, and that's about it. So I'm gonna sort of spiritually close this session and then go back to the live feed stuff, and then I'll crop this out and probably put it on YouTube and then post it to Twitter later. And if you would like to have your free mocap session reviewed, pop into the Discord server. There's a link somewhere, and and just post a request in the free mocap clips channel. With, I think the best way to do it is to share the animation, like the anim vid the MP4 that gets spit out, and then also a link to the zip file that contains the entire session. Just don't pick and choose. Just take the entire folder, make a zip file, and then share it somehow, and I will try to get through it as I can. Thanks for watching, and scene. No, I have to. No, that's fine. Okay, I'm done with that recording now. I'm back to looking. Look, check it out. Back into streamer mode. What's up? What's up, y'all? Now we're on. Now it's just we're just here hanging out. All right, what y'all talk about while I was on doing that? Oh yeah, Trento. There's a free mocap user survey, which is very helpful for things. And actually, I'm not gonna read this because I'm tired and I have a meeting in 5 minutes, so I'm gonna spend 5 minutes recombobulating. I'll check this later. Yeah, no, Dr. JKL. This is kind of like, it's like, because I've been sitting here and it's like, oh, I need to make documentation, I need to make educational content, I need to make all this structured, general purpose stuff, and I do, and I will, but also I can just plop a thing on the video and just talk about it, and basically be like, here's what was done right, here's what was done wrong. This little setup of like, oh, actually, most of my, I was like, that happened immediately. I was like writing stuff down. I was like, oh, there's actually, these are the primary components of critique, and it is and it's good. And I think so. That I think my hope is that I can start doing these and be more efficient with them. And then sort of to keep building them up. It's a good way to like engage the community and get people, like, I want to reward people who are putting the energy into this, especially at this like early sloppy phase, and sort of help give them the feedback that would help them do better, while also, but doing it in kind of like a public enough face that other people who, you know, do it with an audience, right? So that people can benefit from the one-to-one stuff, you know, so that there's like sort of like a bleed over between like one-to-one like mentorship style of education and like the one-to-many, like sort of like the one-to-many form of education that's kind of like the, you know, giving a lecture to the class kind of stuff. Thoughts on ideals, cost, and error values? Lower is good. I don't really have a strong intuition on like what the right number is. I kind of, yeah, we're doing about, we're currently in the process of doing validation stuff to give like, to like compare this to like my traditional mocap system to get those kind of like numbers. But so for now, it's mostly living in this like qualitative state, where I'm just like looking at it and being like, ooh, that's a good skeleton, or ooh, that skeleton's not great. But obviously numbers are important, and wait, you're over there. Numbers are important, and we'll get them in the fullness of time. Okay, I am going to go look at a tree, and Marcus, why you ask all the good questions. T-pose versus A-pose. I use A-pose because it takes up less space. And my set, no, you're good. I will give you a quick answer. So my setup has, when I'm doing my full wingspan, I have a hard time getting it. So I've gone to the A-pose. And mostly it's just doing scaling of the skeleton. So you want it to have a good view of all the relevant dados. So like I stand with my palms facing, you know, you could even do like the little cactus pose, just as long as everybody's all the dados are tracking correctly, especially the hands, because those are the most sensitive. However, that also defines the rest pose of the skeleton. So Vandalo, who made the cool like wobbly elephant video, had a lot of problems because like I think he was doing that, and like anytime it lost track of that. So this is a more natural hand position, like the wrist facing in. So if you calibrate it like this, with that as the rest pose, then when you lose your hand track, it'll snap back out to that normal thing, which is really distracting. So you could keep your wrist in, do the tracking, but then it's not going to see your fingers as well. So these are the trade-offs, many of which would be solved by having somebody who knows more about animation than I do build, improve the Blender pipeline, which will happen also in the fullness of time, because I am a philosopher turned neuroscientist, and I don't know much about animation except through like brute force and YouTube videos. So people with high XP in that space, I think, will be able to give a good feedback. I actually think my next one of these might just be Vandelo's recording because it was so cool, and we can sort of maybe start bringing in like requesting help from more experienced animators on like the right way to set up the skeleton pipeline to have more success and to put things closer to like putting things into the format that the animation game design 3D animation community can use more directly. But yeah, okay, I'm gonna go. But this was fun, and I'm glad that Hughes or Mikey saw it and popped in, and have a lovely day. Mwah. Farewell. Click where's stop streaming. Okay, bye.